Good day everyone. I'll be discussing the introduction of strain. Introduction of strain is in the study of mechanics of materials. Strain is one of the most fundamental concepts. It provides a quantitative measure of deformation in a material when subjected to external forces. Strain essentially describes how much a material deforms in relation to its original size and shape. The study of strain is crucial in engineering as it allows engineers to predict the behavior of structure and mechanical components under various loading conditions. Definition of strain. Strain is defined as the ratio of change in dimension to the original dimension of a body when subjected to stress. It is a dimensionless quantity because it is a ratio of two similar quantities. Strain is essentially a way to measure how much an object deforms, like stretches, squishes, or twists, when a force is applied to it. Think of a strain as a percentage of change. If you pull on a rubber band, it gets longer. Strain tells you how much longer it got compared to its original length. Because it's a ratio comparing the change to the original, it has no units like inches or centimeters. It is just a number that represents the intensity of the deformation. Mathematically, it expressed as strain is equals to change in dimension over the original dimension. There are types of strain. There are several types of strain depending on the mode of deformation. Number 1, normal strain. This is the change in length of a body when subjected to axial load. There are two types of normal strain. The first one is tensile strain. Tensile strain is stretching something out, make it longer. And then the compressive strain is pushing something down to make it shorter. The second type of strain is the lateral strain, the strain that occurs in the perpendicular direction to the applied load. Think of a piece of gum. When you pull it to make it longer, the middle part gets thinner. That thinning is lateral strain. The third type of strain is the shear strain. This is a change in angle or tilt. Imagine pushing the top of deck of card sideways while the bottom stays still. The card lean at an angle. That leaning is the shear strain. The fourth type of strain is the volumetric strain. This is a change in total volume. Think of a squeezing a sponge in your hand from all sides. It gets smaller overall. That is a volumetric strain. We have a problem here. A steel rod with an original length of 2.5 meter is subjected to a tensile pulling force. After the load is applied, the rod is measured to be 2.504 meters long. I'm sorry I forgot to put the question on the problem. The question is calculate the normal strain in the rod. The solution will be this. First is identify the given values. The original length is the 2.5 meter and the final length is the 2.504 meter. First we'll be finding the change in length. Finding the change of length is, the formula of that is change in length is equals to final length minus the original length. 2.504 minus the 2.5 is equals to 0.004. And then calculate the strain using the formula. Strain is equals to change of length over the original length. It's 0.004 meter over 2.5 meter. It equals to 0.0016. The strain is 0.0016 or 1.6 times 10 raised to negative 3. That is our strain for that problem. Let's move to the second problem. A steel wire with an original length of 2.0 meter is subjected to a tensile force. After the force is applied, the wire stretches by 0.25 centimeter. Calculate the longitudinal strain in the wire. This will be the solution. List the unknown values and ensure they are in consistent units. the original length is 2.0 meter and the change of length is 0.25 centimeter. So as you can see, they have different units. So the change of in length will be converting this into meters. So 0.25 meters is equals to 0.0025 meter. So apply the strain formula. So substitute the values into the strain equation. So we all know the strain formula. So strain is equals to change of length over the original length. So strain is equals to 0.0025 meter over 2.00 meter. So the strain is equals to 0.00125. So the value of strain on this problem is 0.00125. And that's all. Thank you.